With all of the talk about cloud services like Google Drive, for example, sometimes people forget that it's also possible to have a private cloud, even if you have a relatively small budget. So you can put a file server on your home network and put a few hard drives in it, and there you go. And there are specialized servers specifically for this that you can buy. Usually they're called network attached storage. If you're talking about, file servers for use individually, essentially, where you attach them to your network, generally through the router. Although you can also put them on a switch, actually, like any other computer on the network. And then you can access that server from all your other computers that are on the LAN. And if you have a very nice one, you can also access it from the internet, although you have to set up your security settings correct. Now, one of the things I did find out is that network attached storage specifically is not something that has a completely objective definition. The most popular definition seems to be devices like this. So basically, a cabinet with primarily hard drives and not a whole lot else. Sometimes there'll be some additional hardware built into it to support things like RAID, for example. Like this one, for example, supports RAID. And some of these enclosures don't even come with hard drives, because the idea is you buy the enclosure and all the gadgets that come on it, and then you buy your own drive separately. And you might not want to fill it up, for example. You might want only one drive or two drives to start out with. And then as you expand, you just buy drives, which are much cheaper than network attached storage. This is in contrast to a storage area network, like a very large corporation or government agency might use, where you have basically multiple storage facilities all linked together for redundancy through fiber channel, which is a protocol for fiber optic cabling, for lack of a better term. And very few people will ever touch one of these systems, even if they're working in a corporation and actually working on it. By touch, I mean they wouldn't consciously be administering it unless that was specifically their job. The idea is that a storage area network operates so seamlessly that it looks as if you just have additional drives on your workstation, when in fact these drives are shared with the whole company. But I'm not going to talk so much about them in this video series. I should add, to explain why I'm doing this video in the way I am, that if you want to buy one of the definitive network attached storage devices, they are a few $100. So there's one of the most popular brands, Synology. And they're charging $254 for that one, without any drives, note. Here's a much larger one, also with no drives, that's closer to $1,000. So you could buy a computer for less than that. So even though people really like Synology stuff and they like network attached storage when they know what they're dealing with, it is not a completely cheap technology. It's much cheaper than a storage area network, because storage area networks cost around $100,000 to start. So obviously it's literally 1,000 times more than the cheapest one of these, or maybe closer to 500 times more, but you get the idea. It's a lot of money. So one thing that a lot of people do is they use a very, very cheap personal computer for this, like an old workstation if they have one, or a Raspberry Pi, because both can actually perform the same function, because in principle, network attached storage is very simple. The only sophisticated part of a network attached storage device is the implementation of RAID, usually. The rest of it's basically software. So if you want something really, really basic, you can use a Raspberry Pi, and as everybody who's familiar with them knows, they're cheaper than the average computer. So you look at most of what's being advertised here on Newegg. I'm not endorsing Newegg, I'm just giving them as an example shopping website because they're popular. Just about all of these are cheap except for this one. And why this one is being inflated so much, I have no idea. This is a very, very high price for Raspberry Pi 3 Model B. There might be something we don't know, but this is an astronomical price for a Raspberry Pi, because you can see all the others are under $100. Even the kits are under $100 on this website. But the point is, new or used, they're very cheap devices, and so if you want something to provide you with a very, very basic server for something like, for example, storage, this could be the way to go. So I'm going to, in my videos, give 2 examples of how you can implement that. Really, really easy ways. And I guess without further ado, I will get to that now. Starting with a system called Samba, or Samba, depending on your pronunciation, which allows you to share the drive, not do a whole lot else, but it's a very simple solution. And it gives you also the full functionality of the Raspberry Pi for other things if you want it for, for example, web server functions or what have you. I will get into that when I give my description, or my tutorial rather. So here we are inside the Raspberry Pi 3 Model B that I'm using for this demonstration. If you're watching carefully, you'll notice that I'm actually accessing it via VNC right here. The reason for that is that it's much, much easier to stream videos this way, or more accurately, record videos. This is not a live stream. And I already know the IP of this Raspberry Pi. It's not on the internet yet. But it is ready to have the necessary software installed. Namely Samba. You only really need Samba. I still can't decide whether to call it Samba or Samba. I have VNC activated and SSH activated so that I can administer it later. Now, in line with what a lot of people do, I have it plugged in directly to the computer I'm recording the video on. Once I actually put it online, I'm going to reboot it on my router. So I'm going to unplug it from my computer and plug it into my router and go back into it with SSH and make some adjustments. But the bottom line is that this should provide a shared directory. But one thing that I should do before I do anything else is to add the storage, because normally you don't want to use your SD card for booting the Raspberry Pi for any kind of serious storage, because the older Raspberry Pis at least are limited to 32 gigabytes. A few more things before I get started here. I mentioned that I was using VNC, but this is not the only choice. Professional would usually administer a Linux server from the command line, like that, but they would probably do it remotely, and if they were using a Windows PC, it would look like this. And this is the Windows command prompt. This is not the Linux command prompt. I just have it juxtaposed over the Linux desktop there, the Raspbian desktop. So if I put in an SSH login here, as long as I only need the command line, this is really all I would ever need. So well, I'm not on the internet here. I'm on my home network. The upgrade of this file server to go on the internet will be a future project, possibly. But if I go to my root directory here, there it is. It's exactly what it would be if I looked at it on the Raspberry Pi itself. Well, formatting is different, but you get the idea. It isn't really necessary if you're going to be using the command line to use VNC. VNC is obviously prettier, and you get to use the graphical user interface, which can be easier, obviously. But this is all good to know that you don't have to use it if you don't want to. And all of this, actually, I shouldn't say all of this. I should say most of this is going to be command line anyway, that I do. So anyway, and one other detail too I should add before I move on. This all has to be activated. So when I set up this Raspberry Pi, I plugged in a keyboard and monitor and used it like a regular PC. I wasn't doing any of this remote stuff. So I had to switch on SSH, VNC, enable and enable. Many organizations might disable these if they're concerned about hackers hacking into it. SSH is sort of the gold standard for secure logins, although generally a VPN would be used also. VNC is a little bit more amateurish because it's easier. But in any case, I'm going to attempt to build this server now. Now, the first thing that we have to look at is the compatibility of the file systems. So, if I'm using a flash drive for my hard drive on this for the actual storage server, well, the actual storage, this Raspberry Pi has to be upgraded to support it because it is running Raspbian, which is based on Debian, which is pretty purely classic Linux. So, because it's Debian, we'll use apt-get. So sudo apt-get install ntfs3g, which is more of a Windows file system than anything else. And we're zipping right along here. And we already have it. It's already installed. That's good news. So then sudo apt-get install exfat, extended fat, utils, and exfat fuse. This might already be installed also, possibly. So 2 are newly installed, and they're still creeping along with it there. Are we still? Yes, I was going to double check that we were still connected to the internet. The files on it won't be available to the internet, but I need the downloads is the thing. So if this is conducted correctly, it won't be easy for anybody to just tap into it, but having said that, they are being kept out, I hope. But this is not going to be a work computer. This is purely experimental. So anyway, the core of what I'm doing is Samba, which allows for file sharing, or sharing of drives more accurately. So put that in. apt-get install Samba common binary, or bin. $37.4 megabytes additional space on top of the what looks like 5 gig there. No, 5 meg actually. I'm used to gigs. So this is a very basic thing. We can go with it. Now it says if your computer gets IP address information from a DHCP server on the network, the DHCP server may also provide information about Win servers, NetBIOS name servers present on the network. This requires a change to your smb.conf file so that DHCP provided Win settings will automatically be read. Now, I'm going to manually modify the smb.conf file, so this will be skipped. So no. Please ignore the following error. That's not something you hear every day. Obviously, the Pi is not monstrously fast because it's a Raspberry Pi. In historical terms, it's decent. Slow by modern standards. Okay, so now one of the weirder things about how Samba works, in my opinion anyway, is that it doesn't share the drive directly. You create a directory that basically serves as an alias, even though I'd imagine that really hardcore IT people would cringe at my terminology here. But if we go to the root directory, as before, these are directories, and you're supposed to create a directory to stand in for the drive in the root directory. So sudo make directory, mkdir, and I think I'll just call it a pi NAS, because why not? And I think I'm doing this right. Yeah. The second slash isn't entirely necessary. And then I have to make it available to everybody because it will be shared. Pi NAS. Yeah. And now the drive has to be mounted to that. So lsblk will bring up our drives. So you can see the SD card below. and the flash drive up above. And notice how much larger well, actually, it's not really that much larger. I shouldn't say that. They're about the same size because they're both basically 32 gig officially, and even though obviously that's not really what they are. So in any case, I will mount that by going sudo mount dev sda1, because that is its internal name. And we'll give it its new name, Pinus. And I'm going to double check it. Looks like it mounted successfully. Technically, notice it's the partition and not the disk, because Linux systems generally make very wide use of partitioning in disks. And that's a trend with Mac OS and Windows too. Almost no computer runs on one partition anymore. And then I configure Samba. We mentioned SMB conf earlier, so if I go to there now, sudo v or vim, or some people use nano. These are text editors, all of them, specifically for programming. So Samba SMB conf. I have to go way down to the bottom to put in the configuration. Oops. Is it fighting me? Okay. So the name of the server, indent, comment. I don't know why the comment is there, but it's generally kind of meaningless. I'm just going to put in the name of the server. For some reason, this is fighting me again. Okay. The path is simple because it's straight to the root. I don't think the spelling is exactly correct, but apparently it's the spelling we're supposed to use. If I run into problems and somebody says, hey, make sure I know, because I don't want this malfunctioning or my video being incorrect. Create mask. I'm juggling my microphone and my keyboard, so my typing is sloppy here. No. Now, the instructions I have for Samba, well, first of all, I got to save this. So, right quit. So the instructions for Samba recommend a specific user to be created. So sudo add user on Samba. I'm doing it this way in part because I will be possibly putting other services on this server. I'll do a different account for each one. So a new password. And then you can put in all your personal details. I'm going to skip this. You can see how it's designed for the workplace, even if Debian insists that this is unsupported. In reality, Debian is pretty well regarded. Okay, so then, for these changes to take effect, I have to restart Samba. It's 2 steps there. Now, the most difficult, or at least the most risky configuration you have to do is this one. So you got to go sudo v or whatever text editor you're using, etc. fstab. The reason this is risky is that it can crash your computer pretty easily, or prevent it from loading. It's more accurate, actually. And what you got to do, you got to go to the end of the file here, very end. Don't put this stuff up above. And then you enter these configurations, assigning, once again, the new volume name to the storage drive, for lack of a better word. And notice that the formatting is not the same as above, but supposedly this is how you have to do it, even though it looks wrong. So, right quit. And then you have to set up a static IP. I already have the right IP, but the point of this is to ensure that you don't end up with DHCP changing your IP constantly. So sudo DHCP CD conf. And we jump to the bottom, and they have some example static IPs. Probably just easier to put in something completely new. Although this is not completely new in the sense of being alien to this computer, because this is what the IP actually is already. My typing again. Obviously, I type much better than this normally. This mic stand is in the way, but I can't really do without it. If I didn't have it, it would be worse. Okay, static. Basically, DNS. Just spelling it out. So, right quit again. This will let me do it. This is fighting me again. Right quit. There we go. Now, I'm going to jump back to the PC where I'm shooting the video, because now I have to map that network drive to the PC. Now, an important detail about creating the account for the Samba installation, the Samba user. The password that you enter when you create the account won't work with Samba. You need a separate Samba password. So, sudo it's on Samba, my Samba user account. All right, so we've added the user to Samba, even though he was supposed to be in there all along. Now I will restart Samba just to make sure that I'm having my changes recognized. So SMBD. Then NMBD. Now, if I jump over to the Windows PC, there's our shared drive in Windows. But several things have to be done. So if you're using Windows 10, which most people nowadays probably are, at least of their Windows users anyway, you need to take this route. So actually I should jump back. You go to this PC, add network location. Next, choose a custom network location. Then you put in your IP, backward slashes, even though the instructions are wrong. So you use backward slashes, the IP, and the shared folder. And it detected it, amazingly. That's good news. And then open this network location when I click Finish. Still need to put in my credentials. And this is a test file that I put in the folder. Now I'll prove it. To verify that we've connected to the correct shared folder and drive, we can jump back to the Raspberry Pi, and as you can see, here it is. And I could add another one. I was initially going to do a Silly Cats demonstration off of YouTube, but then I thought somebody might say, that's my cat picture. What are you using my cat picture for? So, to avoid copyright and so on, I will use one of my own photos. And this will actually be a better demonstration even than a download, because I can show how I can put files into this folder from the other end. So, long story short, if I paste one of my photos into the shared folder, this is actually not going on my computer, but on the Raspberry Pi. But I can access it from the Windows PC like this. Picture of some ferry boats on the Brno Reservoir in the Czech Republic. And if I jump on the Raspberry Pi, you can see it's already displaying. So if I try to open it in the Raspberry Pi, there it is. And conceivably, I could do this from other devices as well. I would have to be able to enter the passwords and so on. The device would have to support the correct authentication. Because again, to reiterate, this is a semi-secure way of holding it. You can't really jump off the internet to get it. But you can access the photos either from the LAN or from a VPN, if you have a VPN. In subsequent videos, I'm going to try and build a version of this that can share photos over the internet, but that's really something different. It's not quite the same as having a file server in your own LAN. These are different things, really. Generally, if you were going to share the photos, send an email or something, or just upload them to the internet. Really, it's about centralization of storage. So in any case, I'll try to elaborate on this in subsequent videos. I'll also show other ways of building a file server too, or network attached storage, if that's the term you want to use. As I've said before, there's a little bit of subjectivity in which term you use. So, thanks for watching.